solids. So this is one of the important matter in the states of matter. And my name is Venkat. I am a Microsoft Most Valuable Professional. Solid, yes, solid is a material that has a defined shape. In chemistry, solid are referred to as states of matter that are not just defined by shape but also volume. If we talk about the states of matter, if it is having a real shape, that's called a solid. And if it is placed in a bottle or something like that, it's liquid. Once if you start heating it, it will become gas, or finally it will be plasma. The typical example is like I got ice or something like that. Once if you start heating it, become liquid, and it will become gas at very high temperature. So solid gas on cooling or compress will become liquid. On cool or compress it will become solid. The same thing, if we heat it will become liquid. If we heat it will become gas. This is how the states of matter are. So this is the actual technical names for the conversion of a particular element into another. So solid on sublimation become gas. Gas on deposition, through process of deposition it becomes solid. On melting of solid it will become liquid. On freezing of liquid it will become solid. Evaporation of liquid become gas, and condensation of gas will become liquid. This is how the technical conversion of an element into another type. As I told, the three states of elements are there. Solid, it's a rigid, it's a fixed shape and fixed volume, cannot be squashed. Liquid, not rigid, no fixed shape but fixed volume. For gas, not rigid, no fixed shape and no fixed volume, and it can be squashed. Cannot be, but it can be squashed. So I'm trying to show you a typical example of a solid becomes liquid and it will become gas. That simple example of solids are ice, cheese, bricks, wood, watch, diamond, glasses. Everything's a solid shape. We got plus 2 intermediate physics 3D videos with us. It's an 8 DVD pack. You can buy it from our Flipkart or GTech website, or you can call us directly. Solid. These are the key points you should understand. Molecules closely packed, strong intermolecular attraction, molecules with a restricted moment, intermolecular space is minimal and not compressible. Liquids. Molecules not very closely held, less intermolecular attraction, molecules with a small moment and more intermolecular space and compressible. Liquids are far apart, the molecules are far apart, weak intermolecular attraction, molecules with a free movement, more intermolecular space and easily compressible. Let's talk about the types of solid forms. Solid, the first one is crystalline. It can be liquid crystalline or it can be amorphous. Under crystalline it can be single component or multi-component. Under single it's polymorphs or ionic and non-ionic. So salt is the ionic compound, like we are eating salt, right? That's ionic. And under molecular adducts it's a solvate or hydrate and co-crystal. This is how the solid forms are subdivided. The first one is crystalline solid. There are 4 types of crystalline solid. The first one is molecular, formed from molecules, usually soft with a low melting point and poor conductivity. Covalent networks is the second type, formed from atoms, very hard and very high melting point and poor conductivity. Ionic, formed from ions, hard, brittle, high melting point and poor conductivity. And finally metallic, formed from metal atoms, soft or hard, high melting points, good conductivity, malleable and ductile. These are the 4 different types of crystalline solids. And the second one is ionic solids I want to discuss. So you are able to see ionic solids. Ionic solids form when electrostatic attraction sticks together anions and cations to form a crystal lattice. In an ionic crystal, each ion is surrounded by an oppositively charged ions. Ionic crystals are extremely stable since considerable energy is required to break the ionic bond. The typical example is table salt or sodium chloride. The second one is metallic solids. Metallic solids is a positively charged nuclei of metal atom are held together by valence electrons to form the metallic solids. The electrons are considered to be delocalized because they aren't bound to any particular atom as in covalent bonds. The delocalized electrons can move throughout the solid. This is the electron sea model for metallic solids. Positive nuclei float in a sea of negative electrons. You are able to see the positive things, and you got electrons moving on, through which some of the solids are able to conduct electricity due to the movement of electrons. We got plus 2 intermediate chemistry 3D videos with us. Is a 10 DVDs pack which you can get from GTech website or you can call us directly. The network atomic solids. Network atomic solids, also known simply as a network solid. The network atomic solids are huge crystals consisting of atoms held together by covalent bonds. Many gemstones are network atomic solids. The typical examples are diamond, amethyst, ruby. And we are talking about the atomic solids. Atomic solids form when weak London dispersion forces bind atoms of cold noble gases. The typical examples of these solids are not seen in everyday life since they require extremely very low temperature. An example would be krypton and argon. So weak London dispersion forces bind atoms of cold noble gases. Now we are talking about the molecular solids. The covalent molecules are held together by intermolecular forces to form molecular solids. While the intermolecular forces are strong enough to hold the molecule in place, the molecular solids typically will have lower melting point and higher and boiling point too low than metallic, ionic and network, which are held together by very strong bonds. The typical example is water ice. The next type of solid is amorphous solids. Unlike all of the other types of solids, amorphous solids do not exhibit a crystal structure. This type of solid is characterized by having an irregular bonding pattern. Amorphous solids may be soft and rubbery. They are formed by long molecules tangled together and held by intermolecular forces. Glassy solids are hard and brittle, formed by atoms irregularly joined by covalent bonds, and the typical example is plastic and glass. These are called as amorphous solid. It's a bit flexible. That's it. Thanks for watching our video, and you can subscribe to our YouTube channel for more videos, and also you can post your questions, queries or doubts in our YouTube videos so that we can help you. And this is our contact number. Thank you.